All right, we're doing section 6.3 for Math 65. This is factoring trinomials whose leading coefficient is not 1. This is a much more difficult process. Trial and error. Determine whether there is any factor common to all three terms. If so, factor it out. Write all pairs as factors of the coefficient of the squared term. That's your leading coefficient. Write all pairs of factors of the constant term. That's your trailing constant. Try various combinations of these factors until the correct middle term is found. Okay, so let's try this one. Okay. I'm going to make it a little bigger for me. There we go. Okay, they don't have any common terms. 13 and 15 are not even. So we are stuck with this 2. So what we've got... Now, I only have one set of factors since 2 is prime. And that is a 1x and a 2x. Because 2 times 1, this is going to give me 2x squared. So now I need factors of 15. One of them has to be multiplied by 2. So how I always say this to myself is factors of 15 that combined with the factors of 2 add together to get 13. Well, 15 is 3 times 5. Well, if I multiply 5 times 2, I get 10. 3 times 1 is 3. I add these together, and I'm going to get 13. So this means that these are my constants. Notice that 5 has to multiply the 2, and this is the term that multiplies the 2. The 1 is over here. Now, since that they're both pluses, that means the sign inside is plus. Okay, so now I'm going to check my answer. There we go. All right. Oops, I erased part of my 5. So, x times 2x is 2x squared. X times 3 is 3x. 5 times 2x is 10x. And 5 times 3 is 15. Now, if I put these together, I get 13x. So, yes, that works. All right, let's look at 7x minus 11x minus 6. No common factors. So, again, my leading coefficient is prime. So I know what my coefficients on x have to be. 7 and 1. No other choice. Factors of 6 that when combined with the 7 and 1, subtract to 11. Okay, so we're doing the same basic idea we did before. Factors of 6 when combined with factors of 7. It's the only change. Subtract to 11. Okay, so factors of 6 are 6 and 1 and 3 and 2. So when I consider 7, I'm looking for 11. 6 plus 7 wouldn't work. 6 times 7, that's way too big. So it's probably not 6 and 1. 3 times 6 is 18. But if I subtract, if I 3 times, not 6, I'm looking for 7. So, 2 times 7 is 14. And 3 times 1 is 3. If I subtract those, I get my 11 that I'm looking for. In this case, it would have been a negative 11. But anyway, All right, so the 7 has to multiply by 2. And the 1 times the 3. There we go. All right, now since I am subtracting to get 11, they have to be, the two signs inside have to be different. The larger has to be negative, that's 14. Well, the 14 was the 7 times 2, so that has to be negative. And the other is positive. We're going to check this. I end up with 7x times x, 7x squared. Check. 7x times minus 2 gives me a minus 14x. 3x times x is plus 3x. Now, these two, a minus 14 and a positive 3, give me a negative 11x. Check. And then 3 times negative 2 is a minus 6. Again, check. So yes, this is a solution. Okay, so, nope. 1, there's no common factors. So I go directly to, now, oops, this one, I am not, I don't have a prime first term. So I don't know what's going to go in front of my x's yet. But notice my trailing constant is prime, so these two are going to have to both be 1s. Because 1 times 1 is 1, it's the only way I can get 1. So now I'm going to get factors of 36. So I have 36 and 1. I have 9 and 4 and 6 and 6. Okay, 36 and 1. Now, since this is a 1, they have to add, all right? They're going to, my factor's going to add to 12. Okay. So, to add to 12, certainly I'm not going to have 36 and 1. But 9 and 4 do not add either. Those add to 13. 6 and 6 does add to 12. So that means I'm going to have a 6 and a 6 out front. I'm adding them together, but they're negatives. So I have to have subtractions in here. So basically, I've got 6x minus 1 quantity squared, because they're identical factors. All right, if I FOIL this, I get 36x minus 6x minus 6x plus 1. This adds to negative 12x. So, again, check. This is the correct answer. Okay. D. I have a leading 2, and that 2 is going to be, is prime. So I have 2x and x. I need factors of 7 that when combined with the 2 is going to add to 11. All right, so factors of 7. Well, that's easy, 7 and 1. So how am I going to get 7 and 1 to add to 11? Well, 7 plus 2, that's 9. 2 times 7 is 14. But I can't add anything to that to get to 11. I have to subtract. So that doesn't work. So it looks like this one is prime. All right, moving on. Nope, can't factor anything out. Notice, though, I have an x squared and a y squared. So that means I have to have x and y in each binomial, each factor. So I'm going to have 5x and y, and I'm going to have x and y. Now, factors of 2, of course, are 2 and 1. When combined with 5, add to 7. Well, that's easy. 5 times 1 is 5. 2 times 1 is 2. 5 plus 2 is indeed 7. So that means my y values have to have a 2 or a 1. So to figure that out, I need the 5 has to be times the 1. So that one doesn't change, and the 1x times the 2y. There we go. They're adding together, they're both pluses. Okay, so I can check this to make sure I've done it right. I have 5x squared plus 5xy plus 2xy plus 2y squared. That's going to add to 7xy. And sure enough, I have my original equation. Oh, look, we have something in common here. We can factor something out. Oops, I'm not sure what that was. Oh, I've got some erasing to do, it appears. All right, we're just going to erase. I'm trying to get rid of this random little purple line down there. Okay, I can factor out, let's see, they all have a 3 in them. So I can factor out a 3, and it looks like they all have an x. Right? 30 is divisible by 3, 3 is divisible by 3, and 6 is divisible by 3. All right, so if I pull out a 3x, this term becomes 2x squared because 2 times 3 is 6, and x squared because x squared times x is x cubed. All right, my next term is x alone because 3x times x gives me 3x squared. The next term is 10 alone because 3x times 10 is 30x. All right, now I have to factor this. 3x, 2x, x. Factors of 10, when combined with 2, subtract to 1. Okay, so 10's factors are 1 and 10, or 2 and 5. Well, since I'm factoring to 1, it's going to be easier, I think, to work with the 2 and 5. 10 and 1 is too far apart. They're never going to do that. So 2 times 5, and I have a 2 and 1. So this gives me 4 and 5, which will subtract to 1. So it's 2 times 2, and the 1 times the 5. Okay, since I'm subtracting, they're different signs, and my larger has to be negative. All right, my larger is the 5. So my 5 is these two interior ones, so that's the negative. All right, so to check this, we have to redo the multiplication. So first I'm going to do the FOIL, and I get 2x squared. Now remember, I've still got the 3x out here. All right, I've got a 4x, a minus 5x, and a minus 10. Well, the 4x minus 5x adds to just a single negative x. All right, when I multiply in, now I distribute in this 3x. So this becomes 6x cubed minus 3x squared times the 10 minus 30x. And check, that's what I started off with. Okay. Long, but not too terribly complicated. Haha, there it is. Yes, that was our prime one. Okay. All right. Now, this is my second method. Factoring using grouping when a does not equal 1. Oh, okay. Well, this is basically, I have a slightly different way of explaining it. All right, so what they're having you do is take the 2 times the 15 and factor that. So 2 times 15 is 30. Factors of 30 that add to 13 are 3 and 10. So if I take this, I can now rewrite this original equation as 2x squared plus 10x plus 3x plus 15. See, I've split the 13 into 3 and 10. Now, I'm going to put in parentheses, I'm going to factor these two separate binomials. So I can pull a 2x out, and I've got x plus 5. And I can pull a 3 out, and I've got x plus 5. So now I pull out the x plus 5. And I've got what's left behind, which is 2x plus 3. So that would be my factored form. Okay, I'm going to make that a little bigger so I have more space. All right, so here, no common multiples to pull out first off. All right, so now I take the 7. That was weird. It was giving me all kinds of dots when that was not what... Look at that. That was very strange. Okay, I take the 7 times the 6, and that gives me 42. And I need factors of 42 that are going to subtract to 11. No, add to 11. So that's 6 times 7. It's not 6 and 7. It's not 11. Okay. So, factors of 42 that I think it's got to be subtract to 11. So, because of this symbol. Okay, so just like we've been doing, subtract to 11. Okay, so since 7 and 6 don't work, I now have 14 and 3. Oh, there you go, 14 and 3. All right, how I know that 14 and 3 work? No, our factors is I look at the fact that that's 2 times 3. So if instead of multiplying the 2 times the 3, I multiplied it by the 7, I would have 14 times 3. So that's still factors. Okay, so if you notice, 14 minus 3 would indeed give me 11. So I can now rewrite this as 7x squared minus, I need it to be a negative 11, which means the 14 has to be negative and the 3 positive. So minus 14x plus 3x minus 6. And if I do this, I can now factor things out. So I have 7x times x minus 2 plus 3 times x minus 2. Factor out the x minus 2, 7x plus 3. There we go. Okay, that's our factored form. All right, 36 times 1, well, that's 36. Okay, I need factors of that 36 that add, whoa, sorry about that. I did it again, didn't switch to highlighter. That add to my negative 12. Okay, so I have 6 times 6, or 6 plus 6. That adds to 12, multiplies to 36. That's my answer. So this means I'm going to have, nope, I'm going to rewrite this. I keep wanting to jump methods. I'm going to rewrite this as 36x squared minus 6x minus 6x plus 1. Factor this stuff. I pull out a 6x. I have 6x minus 1. I pull out a negative 6. I can't pull out a negative 6. I pull out a negative 1. Pull out a negative 1, and I'm leaving behind 6x minus 1. You have to flip all the signs inside of this. All right, I factor out a 6x minus 1, and left behind is 6x minus 1. So again, I have 6x minus 1 squared. Yay. All right. Now I have 2x squared plus 11x plus 7. 2 times 7 is 14. Factors of 14 are 2 times 7, or 1 times 14. They're going to have to, the 2 times 7 has to add to 11. All right, so yeah, so if I use 2 and 1, I have 4 and 7, which do add to 11. All right, so I have 2x squared plus 4x plus 7x plus 7. This doesn't look right, but let me pull it out. So I pull out a 2x. I'm left with 2x plus 2. No, I don't have a 2x in the beginning. Silly me. Okay, x plus 2. All right. I pull out a 7, and I have x plus 1. See, that doesn't make any sense. What did I do wrong? Wish you guys were here. You'd help me figure out what I did wrong. Okay. Factors of 14, 2 times 7. Factors of 14 that add to 11. Yes. No. Oh, is this the one that was prime? This might be prime. All right, what we're going to do is go back a page and see if that one was prime. Well, there we have it. So, that it was indeed prime. So now we only have a couple more to do here. All right, so we have I have 5x squared and 2y squared. This gives me 10, whoops. 5 times 2 is 10, and add to 7, 5 plus 2. Adds to 7. So I'm going to have 5x squared plus 5xy plus 7xy plus 2y squared. Now I factor these and get out a 5x, and I'm left with x plus y. And on this one, I pull out, why do I have 7? It should be a 2. Apologies. You guys probably already caught that. This 7 should have been a 2. 5 plus 2 is 7. All right. So now I can pull out a 2y, leaving me with x plus y. So I can factor out the x plus y. And I have 5x plus 2y. Okay. 6x squared, cubed. All right, again, I can pull a 3x out of this, leaving me with, out of 3, 2x squared minus x minus 10. 2 times 10 is 20. Okay, factors of 20, let's subtract a 4, are 4 and 5. Sorry. Factors of 20 that subtract to 1 are 4 and 5. So I have, don't forget my 3x on the outside, 2x squared minus 4x, plus 4x minus 5x minus 10. Keeping my 3x. It should go there. I can pull out 2x, leaving me with x plus 2. And here I can pull out a 5. Sorry, apologies. A negative 5, leaving me with, hang on, I messed up my signs and now I'm lost. Okay, let's try this again. We're going to get rid of these signs and refigure this out. I'll rewrite that 5 in a sec. Okay. Has to have a negative x, so it has to be a negative 5x and a positive 4x. This is still negative. All right, so I pull out a 2x, I'm left with x plus 2. I pull out a negative 5, I'm left with an x plus 2. There we go. All right. Now, I pull out the x plus 2. What was left behind was 2x minus 5. And there we go. That should be the same answer we got for F on the previous page. And we are done. I hope you enjoy your homework.